Ja, test, 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 test. Jag vet inte. Får du in något nu? Kanske. Funkar? Ja. Ja. Okej.
Ska jag bara snacka i rum eller ska...
Ja, jag kan dra upp den här kabeln.
Kom hålla lite.
Det finns mycket kabel.
Då blir det väl så. Okay. Hello everybody and welcome to NixOS Oslo user group, our first little MiniCon of 2020. First, some practical info. There are toilets and they are in the hall, and you take a right and go through the door where there's a poster that says toilets. There are also snacks on the table behind you, and you can also buy the hacker drink of choice, which is Klubbmate. You can pay with Vipps if you have that, or if you need to pay with card, talk to the gentleman over there that raises his hand in the intermission. There will also be pizza after all the talks are done, so stick around for that. And we'll have about 10-15 minutes break between each session. So first up, we have Elis Hirvik from Sweden, who is going to talk about the Nix ecosystem.
So, hello everyone. I'm going to talk briefly about the Nix ecosystem. It's a big system. I don't know how many in here that are familiar with Nix and have been working with Nix today. So some of you might not know how wide and varied selection of utils there are to do different things in the Nix ecosystem. My name is Elis. I live in Stockholm. 14 years of Linux desktop experience, 3 years of NixOS experience, and I have commit and merge access to Nix packages from being in the project for a while. How many here have experience with Nix as in the package manager? About half. Okay, so this is my agenda today. I'm gonna touch on Nix packages, NixOS, and the Nix ecosystem. Before we start, I would like to mention a bit about Nix, because it's easier to get what Nix packages is about if you know something about Nix, and the other way around. And Nix is a package manager that builds packages from descriptions, like most package managers, but it's also aiming to be very declarative. You will see more about that. So starting with Nix packages. Nix packages is a repository that contains all the packages, like the main repository. And it's written in the language Nix, which is a bit confusing when you're new, because we use the word Nix for a lot of different things depending on context. Nix packages is also a huge software repository, absolutely huge. At least if you count computers and not like app stores for phones. It's not really the same ballpark. Here we have some stats from Repology that index a lot of package repositories. So you can see here that Nix has 49,000 packages, and in amount of up-to-date packages is 23,000 up-to-date packages. So it's actually one of the biggest repositories with the most up-to-date packages in just numbers, which is quite amazing for a community project. And it's a very active project because it's all hosted on GitHub. So it's quite easy for most people to just come with a drive-by commit, fork something, do a change, and push it back. It's not some obscure thing to join. Most people are there. So just for the past month, we had close to 2,000 merged pull requests and 3,200 new commits on master, which is quite amazing for a community project as well. And Nix packages is not a repository for unmaintained software. So if it's a piece of software that is abandoned by upstream, we tend to try to get rid of it unless too many things depends on it, like Python 2. It will take a while to get rid of, but that's the case for every distribution out there, more or less. So, but that's enough about Nix packages. So now we're going over to Nix. I'm gonna mention the project origins, the foundation, the package manager, the store, and generations, like the concept, what generations is, which is part why Nix is so great. The store is also a big reason for that. The project, fairly simple, was started by Elko Dolstra in 2003. It's based on his PhD, and it has grown a lot from there. We have a foundation in the Netherlands. They have on paper at least, the ownership of all core infrastructure. They have an elected board. They host the build farm and the binary cache. So in Nix, we fill the cache to make it easy for people to just download pre-built packages based on the package descriptions. This makes it not as much compiling as it could be otherwise. But it still keeps the flexibility as a source-based distribution could have. And we have the package manager. It aims to be reproducible. But if you know reproducibility, it's quite hard, because some programs may do silly things like include the timestamp of the current time in the output of the build. That is not reproducible if I build it tomorrow. It will be different. Include the architecture of the host, like what model of the CPU it is. Well, if I build it on my machine, it's probably not the same as yours. But it's a goal, not a reality yet. But there are multiple distributions working on reproducibility. And Nix is working on it by being declarative, by building things in a sandbox, by requiring the packages to declare which dependencies are needed. So the sandbox only contains exactly what's needed. And that way we come closer to being reproducible. And the ultimate end goal, of course, is to achieve determinism. So we actually know exactly which binary we will get when we do whatever we do. which might be very different from use case to use case. So, and part of the build and how we achieve this is by using the Nix store. The Nix store is very special because we store all the packages side by side in separate directories. And with the Nix store, we can avoid certain problems that exist in most other systems, such as the following ones. In Nix, package conflicts, they don't exist. Version conflicts, they don't exist. And circular dependencies, they don't exist either, because if you would declare one, you wouldn't be able to build it. So it cannot end up in the store anyways. There are hacks for certain things, but because certain dependencies are weird, but it's always been like that on Linux. So that's not a new thing. And using this store that has this example layout, we have a hash. This hash is fake, obviously, but this hash is based on the build instructions of the package. So it's all the build instructions, and all the build instructions of all dependencies of the package are baked into that hash. And then we append the human name and the human version to make it slightly more readable. And then all the dependencies are linked, dynamically linked, to the things on a specific path in the store. And that way we can achieve dependencies that share dependencies, but they don't conflict in versions, since they are in different paths. And using this file system layout, we can achieve generations. Generations are hordes of symlinks living inside of the store somewhere that describes system or a package by symlinking the correct things together to a single piece, so you can use it. And with generations, we can do things like atomic upgrades, because we can put all the things needed for a desired state into the store and then switch the symlink. And with atomic upgrades, we also have rollbacks, because we can switch back to the older symlinks. This, of course, can come with problems, like if you have a database and the database migrates the format and you try to roll back. Good luck with that. But that's a problem for every distribution. So, yeah, it's not just Nix. But using these superpowers that Nix, the package manager, gives us, they have some very smart people went together to build NixOS, which is a Linux distribution built on Nix and Nix packages. The main difference between NixOS and Nix is that NixOS comes with a module system for service configuration. Because if you just use Nix on Ubuntu, you can install packages, but you're not very interested in the full configuration of OpenSSH, because that's quite out of context for just a package manager that delivers binaries. So NixOS has wrappers to create systemd services and to create the configuration files, etc., for all sorts of services there is. This is an example of the OpenSSH configuration. So I enable the daemon and I disable password authentication. And this will give me an OpenSSH server running with the port open and no password authentication. All the configuration is written, just with those two lines. And then I can do other things like define ciphers or append extra config if I'm not happy with the options available. It will just append it to the file to make it super flexible. And with Nix, of NixOS, we also get system generations because we have those powers within the Nix store. So we get boot generations. So when you boot the system, you get to choose the generation. And so you have the same configuration, but you can boot into any generation, and you can roll back and move forward online as well. You can do whatever you want there. It's very flexible. And you also learn to garbage collect after a while. So this is very powerful, but it's not for everyone because it's a bit different from other systems. Many people have a hard time with the store because it's so different. When I started to learn about using Nix and NixOS, I actually gained a lot of knowledge in debugging Linux overall, because you actually needed the proper tools to look in the right place to find the location of certain files, because they are in the store. I don't know the path. It's a hash in the name. But I'm going to switch over a bit to the ecosystem at large, because the ecosystem is vast. I'm not going to mention even half of the things I know about. Some of the topics here are different platforms, development environments, language tooling, building and deploying Docker images, and operations using Nix. I'm not going to deep dive in those topics, but I'm going to mention bits of it. So different platforms. Nix as a package manager runs on Linux, Darwin, and early stages to run on FreeBSD. Before it could run on FreeBSD through the Linux emulation, I guess, but it wasn't officially supported in any way. And this makes it possible for a team of developers that want to share things to have the same software across multiple platforms. Sure, some software can have bugs on specific platforms, but that happens regardless if you use Nix or not. Then we have like development environments. Have anyone of you used direnv and Nix shell? Yeah, direnv is very nice. It's developed by a Nix guy. It's not specific to Nix. You create a file. It's called .nvarc, and you put it in a directory. And then in that file, you can run things like setting of environment variables. And when you, with your terminal or editor that happens to have support for direnv, you get those environment variables. And direnv also has integration with Nix shell. So if you have a file, shell.nix in there, you can install dependencies when you enter a directory. I have an example of that. It's this file is a shell.nix. I use it when I'm going to generate a presentation like this. So what I do is I define a custom LaTeX environment, because if you download a full LaTeX, it's huge, about a gigabyte or something to download. I don't need that, because I don't need all the languages. So I define what I need, and I get exactly that, and I can just enter the directory, get my LaTeX environment, and build my presentation. And this is in a Git repository, so if others would clone that, they could build my presentations as well. It's on GitHub as well. So this one is a bit stripped down because I have some more things. But for development, we also have language tooling like Node to Nix, Poetry to Nix, PyPy to Nix, and Vigo to Nix, which are just a few of the two Nix tools. There's more. So you can convert dependencies for projects to Nix code to be able to deploy different languages with Nix, because it needs to declare which dependencies to download with hashes and all that to be declarative. There's loads of those. we also use them extensively to package certain bits of software within Nix packages. Because of some things is written in Node, so we need to download Node dependencies. It happens. Another example is Nix can build Docker images. And you can define how many layers you want, and it runs a popularity contest to build optimized layers. So you can have smaller deploys, especially if you have several containers. And there's also Nixory, which is a custom Docker repository for built on Nix, which is super powerful. It's still fairly new, but I think it will be great. When it comes to Docker, there will also be a workshop tomorrow with Adam, who will speak more about Docker things and building Docker images. So I highly recommend that. Another example of great tooling from Nix is NixOps, which is for operations. So it integrates with different providers like AWS and certain providers like that to create infrastructure on the fly and then deploy a configuration. So it just creates the infrastructure needed and does things magically. And then you can change the configuration and it updates the machines running, which is very cool. And I will love to learn more about that when Kim speaks later after me. So I'm getting closer to the end here. I have some conclusions. Nix is a huge ecosystem for building and managing application. It has a proven track record and is here to stay. Basically, partly because its age. I mean, it's 17 years old. It's a lot older than people think. Many people hear Nix and like, oh, is that a new thing? No, not really. It has just grown immensely like the past 5 years. Which is kind of why people are starting to pick it up now. And Nix is also very flexible and can be a good tool for users, developers, and operations. Kind of across the board, in my opinion. And I will leave some contact information up here. If anyone have any questions, you can ask it now. No questions.
About the Nixtor package hash.
Yep.
Does it has anything to do with checksums of the files inside?
What did you repeat?
Like that hash of the Nix package, like in the store.
Yeah.
Does it has anything to do with the checksums of the files inside?
No.
No, it's like you can have different linear files inside, but the same hash of the Nix package.
For a non-deterministic build, yes. Because this hash is calculated before the files are put in the directory. Otherwise, it doesn't know where to put them. So this is based on the instructions. And if the build isn't deterministic, you will get a different output. We have a command you can run. I think it's nix build -- check and attribute name, something like among those lines. Then it will compare. It will make sure to download the file from the binary cache to have it, and then it will build it locally to see if it will get the same files in the output. But not all packages are reproducible, and there are people working on that, but it's a lot of things to do and a lot of moving parts. And I think there's also projects out there that simply doesn't care, and those are a bit harder to deal with.
Is there any marking like to differ non-reproducible
Is there any way of marking packages if they are not?
You can recognize, like, you can find like a list of the packages which are like can be reproduced with the same checksums, which you can find.
It's a very hard. No, we don't have any way of seeing that because it's a very hard thing to get an overview of, because it takes a lot of build power to build it once and then build it again and then comparing it. But there is a guy running a project called r13y.com, I think it is, for reproducibility. And he, in periods, he rebuilds the entire small ISO package set to compare it to the binary cache to be able to see the different for that set of packages. But that's just the small ISO, and even that has some bit to go.
Okay, thanks.
Any other questions? Yep. Not.
Ja, du vill ju prata den här. Okay.
Yeah, doesn't matter. We're ready for our next talk, and this one is on NixOps. We have Kim Lindberger here to tell you all about it.
Yes. Hello, everyone. I'm gonna talk to you about NixOps.
More mic, maybe, or no?
Yeah, is the level okay? Okay,
But
good.
just talk a little louder.
Okay, right. Sorry.
For us in the room.
Yeah. Sorry. All right. My name is Kim Lindberger, and I'm going to talk to you about NixOps. So first, a little bit more about me. I'm from Stockholm, and I'm a board member of the hackerspace X. And I'm a NixOS user and contributor since about 2017. And I'm an IT specialist at Excellent Audio, where I try to use as much NixOS and NixOps as I can. All right, so the agenda is, what does NixOps do? How does it work? Why would you choose NixOps? And then a little bit about the future of NixOps. So what does it do? NixOps deploys NixOS system configurations to remote machines. And deployments are declarative and entirely written in Nix. It can deploy configurations to existing machines that you've set up manually. And it can also provision new machines, such as VirtualBox virtual machines and AWS EC2 instances and Google Cloud Engine instances and more. It can also provision non-machine resources such as SSH keys and subnets and S3 buckets and DNS records and much more. It also handles multiple networks and clouds in the same deployment and can set up encrypted tunnels between hosts. So first off, what is a deployment? A deployment is the unit most operations in NixOps act on by default. So some commands you can specify that it should act on a part of a deployment as well, but by default most commands act on a deployment. And it contains servers and resources that should be deployed together. Everything put into one specification. So let's look at how such a specification is built. So say we have the following NixOS configuration, which, well, just starts Nginx to host the NixOS manual. And yeah, the configuration is pretty simple. Just enable Nginx and create an example virtual host. And in that we set the root to be the path of the NixOS HTML manual. So when you go to this, you will just see the HTML version of the manual. But we want to deploy this using NixOps. The first thing we do to construct our deployment specification is to wrap this in an address set and set it to the node, the name we want for the node. So just simply call this web server, and the rest of the configuration is exactly the same as it was in NixOS. And then we also have to specify where we want to deploy this. So if we want to deploy to a machine in our local network, we can specify that by setting deployment target host. And that we can set to either a host name or an IP address like this. And then NixOps will SSH into that machine and apply the configuration there. But that means that you have to have set up an environment on that machine that NixOps can actually control. But before we deploy to a production environment, we can test it out by deploying to VirtualBox by setting deployment target env to VirtualBox. And this will, with this, NixOps will just create a VirtualBox VM and deploy to that. So you can test it out locally before actually deploying to a production environment. So creating a deployment. To use that configuration that I showed you, we need to create a deployment in NixOps. And we do this with the command NixOps create, which creates the deployment, but it won't actually deploy anything. So it just creates all the metadata that is needed so that NixOps actually knows which files belong to the deployment. And this only has to be done once. So when the files we feed it changes, NixOps will automatically pick that up. So let's just show you how that works.
This is
Oh, right, sorry. I'll increase that. Is that better or
more
there?
More contrast.
That's a bit harder.
that's good.
I think this might be a bit too much. Is that okay? Can everyone see? Okay. All right. So that's pretty much it. Like, we can now check the info, but yeah, it doesn't do very much yet. It's just like we've told the NixOps that there is this file called webserver.nix, and that's pretty much it so far. So to actually deploy anything, we use the command NixOps deploy. And every time we make a change to our configuration, we need to run this command for the changes to take effect. So during deployment, NixOps does several things. It first checks the state to see whether all declared resources have been provisioned already. And if they aren't, they're provisioned. In the case of a machine, it's instantiated, and NixOps waits for SSH access to the machine. And then when it actually has access to the machines and everything is set up, the configuration is built, and the closure of the configuration is copied to the server, and then it activates the new configuration. So let's show you that. Yeah, I'll just do that. The forced reboot you can essentially ignore. It's just because I know this is going to fail. It starts by setting up a new disk image here, the VirtualBox VM. And there we go. So we can watch it boot if we want, but I'll switch back to the terminal. And then it's waiting for an IP address from the VirtualBox, so we can communicate with it. Right. And this takes a little while. I don't have the fastest machine either, so. Come on. All right. And now it actually has access. So it's building the configuration, and the configuration is just the one I showed you previously, the NixOS manual Nginx server. And now it's copying all the built packages over to the server, or the configuration closure. More than expected. All right, it's finally finished. So now it sets up grub, and instead of activating this configuration, it reboots the machine, because I know that it tries to restart the VirtualBox guest VM extensions, and that's going to fail, because for some reason. I guess they're too new, or the version jump was too great or something like that, but just rebooting the machine solves that. So the configuration is, it just works, but yeah. I guess it needs a new kernel or something like that. And then we can actually go to this machine. I can now run the NixOps info again, and then, oh, well, that looks a bit wonky, but but yes, normally it would be a nice ASCII table, and you can see the IP address of the machine here. So we can just go to that IP address in our web browser, and we have the NixOS manual. Yay! Right, so that was the, well, simple demo there, and we can shut this down, or actually we can destroy that machine, because I don't need it anymore. All right. But we can also do split deployments. So in the previous one, we had everything specified in one place. But actually writing everything in the same place as the NixOS configuration, the physical specification, it can get pretty messy and hard to maintain for anything slightly more complex than the previous toy example. But luckily, we're not limited to one specification file. We can use however many we want. And NixOps will just read from all of them and merge the definitions into one. So, for example, to achieve the previous example with a split, we can have just one file with the logical specification, which is essentially just the NixOS configuration. Like, there's not much more in it than that. And then we have the physical specification in a separate file, where we just assign the same name for it in the attribute set, so web server, just as we had for the previous one. And yeah, that works just the same as the previous example. We just have to tell NixOps to look in both of these files when we create the deployment. And yeah, this means that we can actually reuse the logical specification in multiple deployments. So, for example, we can create a production deployment, and that has our logical specification here and the physical specification that we want to use for, say, Amazon AWS or something like that. And then we can have a separate deployment called testing, which has the previous ones that I showed you, where we have just a VirtualBox or something like that. And when we change the the logical specification, we can just deploy to testing first, see that everything works, and then we can deploy the production when we've made sure that everything works as it should. So, and we can also easily reuse any host specification within a deployment, since it's all Nix. So we can just assign the configuration in a let, and then set multiple attributes to that same specification. So this one would simply create two web servers called Web Server 1 and Web Server 2, and they have the exact same configuration, both of them. We can also set up communication between hosts, or rather NixOps does this by default. So by default, all the hosts in a deployment can refer to each other by name, since NixOps actually updates the etc. host file for us. So if, for example, we want to put an HA proxy in front of our web servers, the config file could look like this. So we just refer to Web Server 1 and Web Server 2 by their name, and yeah, NixOps has set up the host file so that those names point to the IP addresses of those hosts. But we can also set up deployment encrypted links too, and that will make NixOps set up encrypted tunnels to the specified hosts. So it automatically creates encrypted tunnels both ways between the hosts. But you specify that on one of the hosts, and for example here we have an example deployment with where we want to use HA proxy in front of the web servers, and then in the logical specification of, or possibly the physical specification of the deployment, we specify that we want encrypted links to the two web servers. And NixOps then creates the two encrypted tunnels, and they will be called like Web Server 1-encrypted. And we can connect to those tunnels on port 80, for example, and that will automatically encrypt the traffic between the load balancer and the web servers. All right, and an important thing is also to be able to handle secrets, which in NixOS is kind of a tricky thing at times. But yeah, specifying secrets as just normal strings in NixOS is not really a good idea, since they will be put into the Nix store in world-readable plain text. So anyone on the machine, no matter what user privileges they have, can read that in the Nix store. So, for example, yeah, we have this, just a database password, and anyone can read that. Instead, we often want to use paths. We want to put in paths to files outside of the store instead, which actually contains the secret. So the only thing that will be stored in the Nix store here is the path /var lib gitlab db password. But then we can set permissions on that file so that only the service that should read that file actually can read that file. But So that's all fine when we do it in NixOS, because then we have access to the whole file system and we can create those secret files there. But how do we do that in NixOps, where we just set up a machine and then it's supposed to be running without any user interaction? So in NixOps, each deployment can define a special address set called deployment keys, where each attribute corresponds to a file which will be placed outside the store on the target host. So, for example, we have deployment keys SSL cert here. So I want to push an SSL certificate and private key bundle over to the host. And so I specify the local path to that file and then set permissions so that it's only readable by the owner. And by default, that is keys, or I think the owner is by default root, and then it's readable by the group keys, or something like that. But yes, with all of that in mind, it's time for a more advanced example. So in the following demo, we'll set up a deployment with 2 web servers and a load balancer. And the web servers use the same logical and physical specification. The load balancer uses the same physical specification as the web servers. The load balancer communicates with the web servers through encrypted tunnels. And it's all deployed to a new VPC on AWS. So let's see. So I'll just show you how this configuration looks to begin with. We can start with the logical specification. And I'm going to adjust the font size, so don't worry. Is that readable, or do you need it bigger? Bigger. Oh, yeah.
More contrast.
Is that?
Yes.
Well, get me a better projector. All right. So first off, in the let here we define web server. And that is pretty much, it's more or less the thing I showed you previously. And then we have load balancer, which just takes where I've just specified that we want the SSL certificate private key. And then in the HA proxy configuration here, we actually get the path to that file when it's pushed over to the server by using this attribute config deployment keys SSL cert path. And then HA proxy also needs to be a part of the keys group to actually be able to read this. And that's pretty much it. So yeah, and the web servers are just, so web server 1 and web server 2 are just set to web server, and then we inherit the load balance and config. Then the physical specification here. All right. So here is where it gets a bit more complicated, where we first have to define an access key so that NixOps can actually use API calls to Amazon. And then we specify a region and a physical specification for a PHP host here, which, yeah, we just set the target env to EC2 and specify which AMI, which disk image it's supposed to use, and instance type, how much disk space, and a few security groups so that we can actually access it, and yeah, a few other things. But let's move on. So much of this is fairly boilerplatey, I would say, but we specify that we want it to generate a new SSH key pair here, and then create a VPC called example VPC, and a subnet to put the host in. And here we have the security groups, so just one security group to open up HTTP access, so port 80 and 443. And then we have one that opens up SSH access to the hosts, which is needed for us to be for NixOps to be able to access the hosts once they're set up. Like, doesn't have to be public access, of course, but well, we have to open up SSH to the hosts so that we can access it at least. Then here we have just route tables, which this is very boilerplatey. Just open up, like connect the subnet to an internet gateway so that we have internet access. And yeah, a lot of this you don't really need to care all that much about, but yeah. I'll be putting up the configuration in a repo afterwards, and the slides and everything, so you can take a look at it if you're interested. And I've tried to comment some things here, at least, where it might be a bit fuzzy. So we also define an elastic IP, so that we then assign to the load balancer. And so that means that we can move the elastic IP from host to host and keep the same IP address, even though we, for example, shut down one server and then just allocate it to, like, set it to a new server. So we don't even have to update DNS. All right. And yes, so for the load balancer, I guess is the more advanced physical specification, but the only thing that is new from the PHP host is that we specify deployment route 53, which is Amazon's DNS service. And I've specified that the load balancer should get the DNS address oslodemo.xlnaudio.com. So I'm going to deploy this to our work, to my
Production environment.
yes, no, not the production environment. One of the reasons I'm setting up a new VPC is I want this to be really firewalled from anything production. But yeah, I'm using my work environment to do this. So yeah, I guess thanks to Excellent Audio for letting me do this. And right, then we can switch to the terminal again. And we'll create this deployment. Oh, okay, well this is, yeah. So just specify the two files I just showed you here in the deployment instead of the other previous one. And I create a deployment called AWS demo. So that's it. And then run NixOps deploy. And let's hope this works. All right, so it goes off there, creating the security routing tables, and yeah, a lot of. Goes pretty fast. Okay, so I created the instances and it's waiting for SSH. All right, there we go. Yeah, while this is working, I can tell you about some other interesting commands. So, for example, NixOps has a command called SSH, which simply SSHs into the specified machine in a deployment. So it's very handy if you want to troubleshoot stuff, and you don't have to keep track of IP addresses to hosts, since NixOps does that for you. So just specify the name and then you're in. And yeah, I showed you destroy, so that just takes down everything in the physical specification of a deployment. So yeah, deletes the VirtualBox image or deletes all the instances in Amazon or such. And yeah, start and stop. Pretty given, like just start all the machines in a deployment or stop all machines in a deployment. But then most operations also let you specify -- include or -- exclude. So if you only want to run this on one host, so say you want to destroy one host in an environment, you want to take down that specific server, then you can do like destroy and then include and then the name of that machine. Or exclude if you only want to keep one machine or two machines, but I guess that's probably less commonly used. All right. Okay. Well, it's still going, but still copying the closure. Yeah.
So
In a moment.
does it
Yes.
copy the files from your local machine or from
Yes.
the... Or
Yeah, it builds everything locally on my machine first, and then it just pushes all that up to the server. So yeah, okay, well now it's done. So let's see, we should be able to access that on Oslo demo. Yeah, I have it there already. And there we go. Not very exciting, but yeah, still just the same thing. It's but deployed in a very overkill environment with 2 hosts and a load balancer and encryption between the hosts. So yeah, we can. No need to keep that around. We can just destroy it. Beep. Oh, yeah, it's fine. All right. Oh yeah, I guess that might be a bit interesting when it just shuts down the machines first and then just, yeah, removes everything. So if you look in the control panel afterwards, yeah, you see pretty much no traces of ever having run this, which is pretty great for testing. All right. And then, yeah, so why would you choose NixOps? Well, because of NixOS. It's one of the main reasons, I would say. So all configurations are built locally before being shipped off to servers and applied. And if there's any error in building any configuration, the whole operation is just aborted. So yeah. And when a configuration is activated, it's pretty much an atomic operation that can be rolled back. Just as, yeah, this is just NixOS stuff, really. And configuration files aren't updated in place. So in contrast to other like imperative deployment systems, such as Ansible, which I tried using before, they often make in-place updates to configuration files. So you specify, like, yeah, go into this file and then make these changes. Yeah, that might break. idempotence often has to be manually implemented in recipes in those systems. So checking whether I've already done this update for every step in a recipe, like, yeah, have I already updated this configuration file? Does it contain what I want it to contain? And that often has to be implemented manually in those, so that we know that we don't make a change twice and break the configuration. And when the system is updated, configuration files that are part of the OS or part of a package, they may not be updated depending on the current state. So, for example, if we've changed it and we use Arch, Pacman wouldn't update the changed configuration files to the version that is actually in the package. And maybe we specify in our configuration that, well, we sort of depend on all hosts having the latest version of that package, and we want to make a change to a configuration file that looks exactly like that, like in that package. And then that would break if we have a mix between new and old hosts. And if an error occurs during deployment, we're often left with a half-updated system. So this happened to me all the time with Ansible, where it just managed to run many of the steps, but not all, and then just aborted. And I was left with some, like, yeah, a half-updated mess where it got to update some configuration files, but not everything that was needed, which not very fun. Yeah, and also because it also does provisioning is one of the big things, to me at least. I use that a lot at work. So setting up and tearing down Amazon networks, and actually describing, like having a good description of the network in one place and not having to dig through the Amazon configuration panels, which are like 100 levels deep until you actually find what you're looking for. And yeah. So on to the future of NixOps. And yeah, I don't know super much about the future of NixOps, but I know that there are ongoing efforts to port NixOps to Python 3, and it's currently written in Python 2, unfortunately. So hopefully we'll see that soon. Yeah, it's a bit late to the party, I guess, since Python 2 support is now officially dropped. Right, and also upcoming is that the backends, the AWS, GCE, and all that, like the physical deployment backends, will be split into separate plugins in an upcoming release. So this is already done in master, but there's no released version yet where this is the case. So all the plugins will in the future be placed in their separate repos, and or all the backends, I should say. So they implemented a plugin infrastructure rather, where I guess the reason for this was to make it easier to write your own plugins and maintain them separately, because previously everything was just in one big repo, and there were a lot of forks with different backends, and some of them got merged and some of them didn't, but people used those backends anyway, so yeah. All right, so then on to a summary. NixOps deploys NixOS system configurations to existing machines that you've set up or newly provisioned machines. It can provision both machines and non-machine resources. And NixOps owes many of its selling points to NixOS. And yeah, that's pretty much it. Any questions? All right. Yeah. Alex, I guess.
Yeah. So have you used Terraform? And is it better or worse or just different?
So I'll repeat the question. The question was, have I used Terraform? And is it better or worse than NixOps? No, I have not used Terraform. I've read about it, and it seems interesting. I guess one of the main pros of Terraform would be that it's a very much more active project. So the backends are actually maintained probably quite a bit better than in NixOps. So maybe a potential future for NixOps would be to actually, or any alternative to NixOps would be to actually wrap in or write a plugin to Terraform to use the backends there and then deploy NixOps and NixOS machines. There is a project called TerraNix, where you can write Terraform specifications in Nix. But unfortunately, that's where it ends. Like you can't specify host configurations in that same configuration. It just deploys, for example, like Debian boxes or something like that. So, yeah. All right. Yeah.
In Terraform, there's this state management thing
Mhm.
where when you write your configuration, as I understand, you kind of need there's some states and mix-ups that you need on your computer, right? Like you
Mhm.
can't just with Ansible just mute it to another. And
No.
how is that managed in NixOps?
Okay, so the question was that how is the state managed in NixOps? Since it keeps track of physical resources and such, it has to keep track of that somehow. And yes, NixOps creates a local SQLite database and stores everything in that. And you can export that configuration using, I think it's -- export. And then it just prints the configuration in a JSON format. But yeah, then if you want it to be like a multi-host setup, then yeah, you need to somehow wrap that. So either like what I do is just wrap the export and import thing in a script and automatically commit that to a Git repo and push it. But the more optimal setup would be to actually have proper database support, like external databases, maybe Postgres. And yeah, exactly. That would be great, but yeah, we're not there yet, unfortunately. But how am I on time? Actually, I don't know. Okay, good. Yep.
I think there's one more question.
Okay. Yeah.
Well, I've seen some people using Nix on macOS. Could you
NixOps
you
or?
said you built local packages in
Mhm.
your machine and then push it to the VM or something.
Yeah. Yep.
Can you build packages on macOS and push it to the Linux machine?
So the question was, can you build packages on a macOS machine and then push it to a Linux machine? It's a good question. I haven't seen NixOps being used on macOS, but yeah, I guess it could be done. Yeah, I'm not sure. It's yeah. So. I'll yeah. The main use case, I guess, is on Linux or on NixOS. You would probably use this, and yeah, maybe on other. It probably works on other Linux distros as well, because I don't see why it wouldn't if you have Nix installed. But macOS, maybe a different beast. Yeah.
I'm just going to add, it works on macOS if you set up a Linux remote builder. But you need,
Right.
you need to do
Right.
remote builder, like a remote builder. You cannot do cross compilation and things for NixOps.
Okay. So yeah, added that yes, you can use it on Mac OS, but you have to set up a remote builder so that it builds on a Linux machine. It can't build it locally, which makes sense. So.
I have one more quick question.
Mhm.
You shown one of the configs where when you interpolate a path to a SSL certificate or something,
Mhm, mhm.
like you use config word, but I didn't see like where it comes from.
Let's see.
Like, is it some implicit word or just argument from a function?
Where did you? Oh wait, maybe this was just in the.
Okay, show it in the video or something.
Let's see. Okay, logical. There we go.
Yeah, here.
Yeah. So
Config where it comes from.
yeah. So it's in the. Here you
I
can see. So it's in config. So you access the configuration that way. And yeah, that's where it is. It's not it's a pretty long path to access it there, but it works great. So. Oh, right.
One more question on there.
Mhm.
And,
Yeah.
one more
In
question.
the
Right.
ASD one, do you have like you specified a image? Like
Mhm.
what kind of image is that? Is that an NixOS image or?
Yes, it's an it's a NixOS base image. So I've built my own NixOS AMIs because I wanted them to be on encrypted disks, on encrypted storage. So then I had to create encrypted images in our network. I couldn't find any other way to just reuse like one of the upstream images and encrypt that. So I had to essentially build NixOS and upload that to our Amazon setup, and then copy that disk image over to an encrypted something or other. I don't know. It's a pretty complicated setup just to get an encrypted image, but that's what I've done, and I guess it's probably a pretty old NixOS image by now, but yeah, still works. So, all right, and that's it.
Alright, we'll take a 10-minute break and then we have the last session.
Ja. Hoppa ur.
Just march it.
All right, time for the final talk of the evening. Before we get lost in the pizza mess of it all. And then we have a talk on the Nix language by Adis Bladis.
Cool. So I'd like to start by who am I? Let's get that over with quick because no one really cares. I used Nix first back in 2015 after an IRC friend went on and on and on about how great it was, and I was like, just shut up. I'll try it. And then I got stuck in the NixOS ecosystem since then. I'm working as a DevOps engineer at Twig.io. We do Nix consulting and Haskell consulting and other things like that. I've been a member of the NixOS project, so Nix packages, since 2017, which means I review and commit pull requests at occasions, and the author of a number of to Nix tools, among others, the mentioned in Ili's presentation, which was Vigo to Nix and Poetry to Nix. So let's just first start with these three nice buzzwords that everyone keeps hearing about Nix. So firstly, it's not an imperative language. It's not anything like Python or anything. It has more in common with languages like Haskell and Lisp. It is lazily evaluated. So unlike, which we can quickly demonstrate by firing up Nix repo and say x equals a list of 1, 2, and see that these ellipses things here means that this so-called thunk has not been evaluated. So we really leave that up until something tries to evaluate the x property and walk the list. We only, up until that point, we haven't really calculated what's inside there. And it is functionally pure. So like nothing you do has side effects other than, of course, some things have side effects in terms of files ending up on disk and things like this. But these are strictly controlled side effects controlled in derivations. So let's just have a look of what a typical derivation looks like quickly. At this point, I guess most of you don't really understand what's going on here, except it looks sort of like JSON, but it's really not. And then you have this funky syntax up here, which you probably don't know what it means or anything like that. So let's just build up our knowledge step by step of the language, and then we will revisit this expression in a bit. And hopefully you'll understand a bit more about what's going on. So Nix is an untyped language, so it is dynamically typed in that like functions are not specifying which types they take. We don't have a static type check or anything like that. Though the NixOS module system has types implemented in Nix itself. So it has type checking. I mean, of course, Nix itself has types. They're just not enforced. So let's start by looking at some simple strings. So we have simple, of course, the super trivial strings. We have multi-line strings where like each one here starts with two indents, which means that the indent is removed from the actual string. So if we go back here and look again, we can see that this long description here, it's not very nice that if we have to align things all the way to the left. So we do this so we can write a really nice string where the indentation makes sense. And we also have a special syntax for URLs, but this is, I believe it's already deprecated or on the way to being deprecated.
The RFC is approved.
Okay, so yeah, the RFC is approved. The last syntax there that is deprecated, I just wanted to mention it in case you encounter it, but you shouldn't write expressions with this anymore. Next has paths. And paths is special. They're not exactly like strings. So if you try to coerce one of these paths into a string, that path is hashed and put into the Nix store. and stuff like home directory things are also expanded. Then we have this one I call iPath. I recently just learned why we have this syntax. So this is referencing an environment variable called NixPath, where Nix packages is a property inside this environment variable. And this syntax here, I recently just learned, was inspired by the C syntax for include. So this is really like the Nix include path. So we have scopes. So because it's a functional language, you can't just randomly, willy-nilly create variables everywhere, all over the place. So you need to create a scope for variables, and this scope is recursive. So if X tries to access Y, that's perfectly fine. We have attribute sets, which are sort of like dictionaries in other languages, but they are, of course, immutable. And here we can see an example of, I forgot to put a rec keyword there. So this won't evaluate, but if we put that rec keyword here, it will evaluate, because it's suddenly a recursive attribute set, which means it can reference keys on itself. So a very common idiom in Nix packages, for example, is to set these attributes called pname, version, and then access these attributes in the source URL calculator. So personally, I absolutely hate the rec keyword. I think it should die in a fire, and I will explain a bit more later, but let's skip over for now. Nix, of course, being a functional language, has, surprise, functions. It has really two different kind of functions. One is a regular lambda, the first one. Then we have keyword arguments, where you can pass structured sets into a function, and these sets are decomposed and and scoped in the function. So calling a function is just a matter of, well, first we define this function, which takes two arguments, x and y, then multiplies x by y, and so this entire expression encapsulates the function, calculating the value, and then it returns 50. So if we dive a little bit deeper into what we can do with keyword arguments, we can do a few interesting things. I've tried to put them all into one slide, but I think it's complete. So this is your regular, like standard env. It means you always need to pass in stdenv as an argument to this function. libz is another argument to this function, which has a default value null. So you can specify keyword arguments with default functions. And these are also recursive. So you can say standardenv.lib, for example, in... Let's demonstrate that real quick. So this is a fairly common idiom, where you have a function that takes packages and lib. But let's make lib dot, and let's say we want to return the concat strings function. So we assign this one to a name in the REPL. We call it. Okay, we need to pass packages. So let's pass packages, and this returns a new function which can concat our strings A and B. So which means that packages is an attribute set which we can infer lib as a default argument from. Then we have this weird syntax, which means ignore any unknown arguments. So now I can pass whatever I want to this function, and it will silently ignore any unknowns, while still enforcing that you need to pass, for example, standard env. And then this little funky syntax here, the @args. So the @ is the syntax bit. Args is just an arbitrary identifier for these things, which is all the arguments actually passed to the function. So if we combine this ellipsis with the args, we can extract unknown things conditionally in the function body, for example. And then for completion, I just put another thing there so that we can return. But for now, let's skip that. We have currying, which is really, really, really cool, which means you can take take an argument. No, you can take a function, apply a single argument. What you get back is a new function. So in this case, mul5 would return 50 because we have statically said mul5 apply 5 to multiply. And so what you can really think, yeah.
Is it possibly to partially apply y without x and redefining multiply?
No. You can really think of this as not just one function, but actually it's two functions. So for each thing, you just go further, go deeper into the function stack. So whenever you see like a 5-argument function, it's not really a single function, it's a set of functions.
I believe you can implement
Huh?
leap or something.
Yeah, of course you can do that. With a bit of wrapping, you can do exactly what you wanted to do, but you can't do it as a generic kind of. Well, Nix has a number of interesting built-ins. I just grabbed a few for as examples, but like any functional language, we have map, we have reduced, but it's not called reduced, it's called foldal. Depends on which language, which functional language family you're coming from, what that's called. We can throw exceptions at runtime saying, like we can't evaluate this on x86-64, for example, these kind of things. We have some serializers and deserializers like to and from JSON. We have more deserializers than serializers. And I think that's largely a side effect of JSON being very easy to convert into other things in a derivation, but we can't do it the other way around. So you can't create a derivation that converts something into something that Nix can read and then import that without a number of nasty side effects. So yeah, I already mentioned recursive attribute sets. I just wanted to add them on a separate slide as well. So self-referencing attribute set. We have width, which is scoped attribute set. So these two examples here, they are equivalent, where we can say width packages, which means that for the rest of this expression here, the packages attribute set is scoped, so you can access attributes directly on the attribute set. So I prefer the second approach, where you are much more explicit. And a lot of the time, I think what you should be doing when you are reaching for the width keyword is use the inherit keyword instead. So let's say we want to make a list, much like we are doing here. We take an attribute set, we grab some attributes and make a list from it. So much preferable is using is directly accessing attributes, because it makes code so much more readable. And as someone reviewing pull requests in Nix packages, sometimes with keywords make me go like, okay, what's going on here? Unless function names are completely obvious. Yeah, and also nested with, so with packages, with lib, etc., makes things very, very, very hard to reason about where things are coming from. So personally, I absolutely hate the with keyword. Also should die in a fire, but people keep using it anyway. So inherit is a pretty cool feature, since we work a lot with attribute sets in Nix. We need to be able to grab variables from different attribute sets and scopes and create new attribute sets and scopes. So in this example, we make a set called SumSet and create a new set from that, where we only inherit the Y property. I think this is a really nice thing, especially when you work with multiple scopes and you like inherit SumSet Y, inherit packages, something else. We also have ternaries that looks like this. If true, then yes, else no. throws and asserts. And because Nix is a functional lazy language, these throws look a little bit, may look a little bit strange to some people, but it's because, so if true, then throw, like we always have to put things in ternaries because we don't have if statements like a lot of other languages do. We have assert where we can assert things which will blow up in your face. It can be quite tricky to recover from some assert sometimes, but
I've never seen you can like separate expression with a semicolon.
huh?
Like I never seen you can
Oh,
expression with a semicolon.
that's a special thing for us. So the statement was, I've never seen you can separate expressions with semicolons. And no, you can't, but this is a special case for asserts.
It's on for assert only.
Yes. So, I mean, you can separate expressions in scopes, for example, with these semicolons, but this kind of thing is not a general thing, it's an assert thing only. And this expression will return the result of x plus y, but assert that 1 equals 1. So a pretty cool feature of attr sets is creating deeply nested attribute sets in a single line. So I think in Tali's presentation you saw a lot of examples where you have these kind of file systems dot something dot some other option, which is actually desugared into this kind of JSON-like deeply nested structure, which I think is pretty cool because it makes these really terse configuration lines expand into some really nicely structured data. You can also access so we don't know if hello is there, so we just say packages.hello or packages.world, which means we try to access hello. If it's not there, we access world. Pretty funky operator in Nix that I haven't seen in any other languages is the double slash operator, which is not a comment in Nix. It means you take this attr set A equals 1, concatenate it with B equals 2 with the right-hand attribute sets taking precedence. So if both of these things define A, the rightmost one will take precedence over the first one. So this is also, like, because we work so much with attribute sets, we need a lot of nice operators and help to deal with these. Yeah, we have the regular Boolean operators. Let's just skip ahead. String interpolation, which you saw before. String interpolation for packages is quite interesting, but we'll get into that a bit more later on. Yeah?
I see for some strings you use two single quotes to separate them, and here you use triple quotes.
No. Huh? I think this was a mistake. It should be 2 single quotes. Yeah, so my bad. Yeah, so just your list of operators is not very interesting. Let's go on. So now we can get back to this derivation I showed you in the beginning and try to read this. So we now know what have we done up here? We have defined a function that takes the argument standard n and fetch URL. We then, from the attribute set standard n, we take the attribute make derivation, which is a function, and we pass that a recursive attribute set that contains these pname versions, source, do check, which means run tests. And we apply a bunch of metadata of the derivation, and this doesn't actually go into the hash calculation. So metadata of a derivation can change without the derivation needing to be rebuilt. So do we have any questions on this, like what's going on here? Is everything perfectly clear so far?
Didn't you hate with?
I hate with. This is grabbed directly from from the GNU hello derivation in Nix packages. No, no. So what we have done here with standardm.lib means that we have scoped standardm.lib for this entire expression, and the expression is the attribute set, which means that, for example, licenses is coming from standardm.lib. So if we remove this, we would need to write out standardm.lib.licenses.gpl3.
Platforms.
Yeah, and platforms and maintainers and all of these things that live in standardm.lib.
But only for the right-hand side of the assignments, because the left-hand side is just a name.
Yeah, exactly. Yeah, so that's just an attribute set that gets handled by the standardm make derivation function.
So the function calls, are they like location-based or name-based? Like when you call a function, is the first attribute always the first argument always the first, or are they based on the names?
No, the first argument, so it was a question about when you call a function, is the argument name-based or location-based? It is location-based. If you want name-based, then you should create a function that takes these attribute sets.
Can you comment on the indentation with the double single quote marks? Like
Yeah.
the multi-line string, does it get indented or?
It gets the, I don't know what the word is, but dedented or.
Okay.
Yeah, so imagine that all of the white space here is removed. So if you actually, let's look at it in the repo. Meta.long description. So if we use this, yeah. So you can see here it's completely like, yeah. Yeah?
As a reviewer, do you prefer, and there's a function that has multiple parameters, do you tend to prefer the kind of nested lambdas with multiple parameters and then the location-based, or would you prefer, do you think it's wiser to have a single parameter that is an attribute set?
So the question was, is it preferable as a reviewer of Nix packages to see functions taking positional arguments or these attribute set functions? And I would say it depends. It's no one size fits all. They're both there for a reason. Usually, like if your function starts growing in what it accepts, like the standardm make derivation, it's not feasible to have a standardm make derivation that is positional. Yeah. Any other questions so far? So we can look at this NixOS configuration, which I think is pretty interesting because now we're looking at these options again, which gets desugared into this. So what we are looking at here is actually a function that takes config packages and creates this attribute set with deeply nested things, which gets desugared into something looking a lot like this. Obviously too verbose for me to want to write, but that's what happens. And when your NixOS configuration is assembled, like the final thing is calculated, what happens is we take these attr sets and recursively merge them together according to a merge priority algorithm. So basically the options have option weights. So you can say, I want to define this thing, but with a higher weight. So somewhere in your config, you have services.sshd.enable false. Somewhere you have enable true. Which one goes first? Well, in that case, you get a collision saying you have specified this multiple times, but you can also say, apply this with the weight 41, which is higher than the default of, I believe, 10, but I can't remember. Yeah?
When you merge attribute sets with a double slash, is that a shallow attribute set merge, or does it actually do the whole recursion?
So the question is, when you merge an attribute set, is it a shallow one or a deep one? It's with the double slash operator. With the double slash operator, it is only shallow. But what the module system does is like from the inside out. So that's probably more intuitive.
So there's presumably some function in the built-ins that can do that for you?
It's not in the built-in, so that's in the Nix package's NixOS module system. That's not in the language itself, really. A pretty cool feature about Nix is that strings carry context. So when you look at a string, so we take this derivation hello, we coerce it into a string, apply some extra stuff to it, but if we then put this into another string, that will carry a context referencing the derivation hello. So if you, for example, in your systemd service definition, say I want to exec start this Nix store path, how that actually ends up on disk in the correct location that you expect it to be is through the string context propagating through all your strings, and then when your string is realized, it also knows what derivations need to be realized.
And is that because it's lazily evaluated?
No, that's because strings carry a context. So I believe it's built-in has context. Yeah. Hello, whatever. It doesn't have context, but so there is sadly no. So this we can't introspect what the context is from the Nix language itself, but when you coerce something like this, it means that this string carries a direct reference to the hello derivation, which is propagated through when you concatenate strings or interpolate strings. That's always passed through. And if you don't want that behavior, you can use this unsafe discard string contexts, and then you might end up with strings pointing to absolutely nowhere. So yeah, this is what I mentioned it before, but this is why I don't think you should be using with a lot, especially not on the top level. So if we go back to the hello derivation, I think this is mostly fine because it's very narrowly scoped what can be referenced where. But if we move these with statements up there, suddenly there's a whole lot more to reason about. So I mentioned why I don't like the rec keyword. It's because it breaks overrides somewhat. So what do you expect happen if you are trying to override this derivation and set do check false? What do you expect happens with this one if you call the override address function? Well, what will happen is that since this is already do check is only at derivation instantiation time, what will happen is that pybind 11 test, this make flag will be set to on even if you override the do check attribute. So we can desugar this rec attribute set into this. This is what it actually looks like without the syntactic sugar. And we can show even more why this is a bad idea when we start reasoning about evaluator performance. So it's a very common idiom to have a let block up there, and then you do your derivation stuff there. But in this case, we will actually have created a number of scopes. So we will have created 2 scopes where we only need 1. Because if we look at this one again, what actually happens to this rec thing is it gets desugared into something sort of like this. But if we have both a let and a recursive address set, we have now created 2 scopes, which will increase memory in the Nix evaluator. So I would most of the time just say, don't use rec keyword, just use a let block up there, and things are much easier to reason about. So some takeaways from this talk is, I think Nix is a small, simple, and I think very easy language to learn once you wrap your head around that it's not an imperative language. So when I finally realized that this language is essentially a bit of a weird Lisp without the parents, things clicked into place instantly. And learning the language really gives you awesome superpowers to dig into your system and change things at a whim. So you can definitely use NixOS without learning the language, but it will take you so much further if you really learn how to program your system. Thanks. Yeah, questions?
For learning to use the Nix language,
Mm-hmm.
do you recommend just using the REPL, or is there a better way to play with the language?
I think the REPL is the best way.
Okay, and just load files from the REPL.
Yeah. I mean, it can get really difficult to use the REPL if you want to create bigger programs and stuff, but yeah. No, for just learning the language, explore things in the REPL, it will get you really, really far.
Sometimes trace function helps.
Yes. So one person in the audience mentioned this one. So built-in trace is this thing that has a side effect of printing a message and then returning a value. So built-in trace hello will trace hello, and then it will return the second thing, which is world. So yeah, that helps a lot when. Yeah. So another question.
Yeah, even though this is a special purpose language for build configurations and such,
Yeah.
have you found yourself using it for other things?
Yes, like graph problems, I feel like are very nice to express in this language. So yeah, I should repeat the question. The question was, have you used it for other things, even though it's a special purpose language? Yes, I've actually written complex, ish programs, like 1,500 to 2,000 lines of code in Nix, and that's fine. Any other questions? No. Yeah?
Yeah, you said that there is no recursive things or recursive merge, but there is one called recursive update.
Yeah. So I said. So yeah. The statement was I said there is no built-in for. No. Yeah. So for recursive merge of sets, but yeah, there are functions to do so. There is just no built-in operator to do so. Okay. Thank you.
I would just really like to thank everybody for coming. It's been awesome having so many people here. We still have one day tomorrow where Adis is going to talk about how to build Docker containers with Nix. And we were planning on having like a package kind of workshop after that. If anybody has anything they want to package for NixOS or for Nix and need help or want somebody to look at their pull requests, we'll do that stuff tomorrow. I give the word to Salve, who just wanted to say a few words about Hackeria, and then there is pizza time.
I'm not going to keep you